G'day Year 12s, just reminding us of some of our old Year 10 work today. This is exercise 13D, area of a triangle using trigonometry. And all we're going to do is look at the fact that we can use the rule, well, I'd say half AB sine C. They've got it written as half BC sine A. It doesn't really matter how you write it, as long as you have two sides and the included angle, you should be able to find the area of a triangle pretty quickly. Let's have a look at and why this actually works, because it's really important that we understand why our rules work in maths. So we've got our triangle over here, and the rule we definitely know for triangles is that the area is 1/2 of the base, which in this case is B, and the height, which is h, perpendicular height. Okay, well, how could I rewrite h using trigonometry? Because we've got some trigonometry there, so let's see if we can use it. Well, this is angle A. Can I find an expression for h using angle A? Well, h is opposite angle A, so I'm thinking SOHCAHTOA. I've got two options here. I can go with the sine or tangent ratio. They both use the opposite side, but when I look at the tangent ratio, I don't have a nice expression for the adjacent side, do I? So I can't use that, so I'm going to use my sine rule. Well, what would the sine ratio be for that triangle? Well, the sine of angle A is the opposite side, h, divided by the hypotenuse, c. And my pen wants to play up a little bit, which is equivalent to c multiplied by sine A equals h. So if I make that substitution over into this original equation, I'm going to say let h equals c sine A. I'm now going to have the area equals 1/2 B C sine A. And there you go, you've proved it already. Could I have used this other side of the triangle? Of course I could have. Let's see what we'd get if we did it that way. Here I would have the sine. I'll start with the sine because it's easier if we start with the ratio and then rearrange it. So the sine of angle C. Oh, these styluses are getting old. Sine of angle C, the opposite side, h divided by the hypotenuse A. So A sine C is equal to the height. So where I've got the area equals 1/2 B times h, I can now say let h equal A sine C. Therefore the area is going to be 1/2 AB sine C when I substitute it into our original equation. And that's all there is to it. Quickly looking at how would an example work with this. Find the area of the triangle. Well, the area of this triangle is going to be 1/2 times 7.2 times 6.5 multiplied by sine of 140. Now I'm going to put approximately equals 2 because I am going to use the calculator to tell me the sine of 140. It's not one of our nice angles that we should know an exact value for. Typing in on my calculator here, this is where I'll probably make a mistake. By sine 140, I'm checking, yes, I'm in degrees mode. So this is telling me the area is approximately 15.04 square centimetres. That doesn't seem unreasonable given those values that are there. We'll take it as sounding okay. Find the area of this triangle to 3 decimal places. What's our problem? That's right, we don't have an angle, so how can I use half AB sine C? Some of you may know Herons' formula. The area is equal to the square root of S minus A, S minus B, S minus C, where S is the semi-perimeter, half of A plus B plus C. There's a rule you could use to work this out, but that's not in our maths methods course, so we better give you the one that they'll probably be expecting in the exam, but it's a good way to check it if you want to check your answers that way. What are we going to have to do? We're going to have to find an angle. Let's find angle A. So, using my cosine rule, 6.4 squared equals 8 squared plus 10 squared minus 2 by 8 by 10 cosine A. That's what we're working with, isn't it? Oh, 64. That's 2 to the power. Oh, but it's going to be a 0.2. It's going to be a mess. I'm just going to go for my calculator on this. So what am I going to do? I'm going to add that to 6.4 squared. So I'm going to have 6.4 squared. Stylus really misbehaving today. Minus 64 minus 100. Well, this makes for an exciting video for you, watching the stylus not work every time. So I've subtracted these two values. Now I can divide by that coefficient. I can't just add it to the other side because that's going to be a mess. So I'm going to divide by, what is that, negative 160 equals the cosine of A. So A is going to be the arc cos of whatever that expression was equal to. Well, let me tell you what it was equal to. 6.4 squared minus 164, save myself a little bit of time, divided by negative 160, and that's 0.769. A is approximately equal to the arc cos of that. Arc cos of the previous answer, 39.74-ish degrees. Can I find the area of the triangle now? Yes. Area. So I should really list that as angle A, and here I'll write A with a triangle to indicate that I'm finding the area of a triangle. Otherwise, it's going to be a little bit confusing there. The area of the triangle, so it's going to be a half of 8 by 10 times the sine of 39. Whoa, 93. Good work at Listexia there. 39.74 degrees. Now I haven't got rid of that angle on my calculator. You can see I didn't bother just abbreviating it. Even though I write it to two significant figures, or two decimal places there, 4 significant figures, I'm going to continue and just use the whole value if I can. So I want to go half of 8 is 4 by 10 is 40. So I'm going to go 40 multiplied by the sine of my previous answer. And I am getting 25.57. Do we have some units? Square centimeters. How does that compare with Herons' formula? Do you want to have a go at that? Oh man, it's exciting enough. Why wouldn't we? What do we got there? 10, 18, and 6.4, 24.4. So S equals 1/2 of 24.4. which you've already figured out and said in your head. So that's just 12.2. So the area is going to be equal to the square root of 12.2. 12.2 minus 6.4, which would be 5.8. 12.2 minus 10, which will be 2.2. And 12.2 minus 8, which will be 4.2. And I'm going to do that on my calculator just to see. So 12.2 multiplied by 5.8 multiplied by 2.2 multiplied by 4.2 is equal to 653.82. I need to square root it. 25.57-ish. Square centimeters. Look at that, just like we expected. So you've got a couple of ways you can do those ones. It's just a quick refresher, this one. Just do a few of the questions, make sure you can do them. There's also a skill sheet there. If you feel like you needed a little bit more practice, you can. You are always welcome to do all the questions, but that should be enough. Thanks for listening. I'll see you in class shortly, or I saw you in class before this if you haven't looked at this yet. Either way, see you soon. Bye.